CAPS with no mutation. CAPS is an autoinflammatory disease caused by mutations in the NLRP3 gene that make the NLRP3 protein overly active, resulting in unchecked systemic inflammation. The inflammation action is mainly carried out by a pro-inflammatory cytokine called interleukin-1 beta that becomes activated by the NLRP3 inflammasome. CAPS is treated with Kineret or Anakinra, which blocks the interleukin-1 receptor. In the Infevers database, at the time of making this video, 262 NLRP3 variants are listed, with 123 of them classified as pathogenic or likely pathogenic. Mechanistically, we don't know how each mutation creates the functional problem in the protein. There are ideas about it that make plenty of sense, but until it's been shown through experimental work, we can't say for sure, which is how science works. So what if you have suspected CAPS with all the symptoms and no mutation is found? All this means is that none of the known mutations have been found. And let's remember, 20 years ago, that would have been all of us. New discoveries are happening all the time. 6 new pathogenic or likely pathogenic mutations were added to the Infevers database last year. Welcome to our newest members. Here are some fun facts about NLRP3. The complete protein is made up of 1,036 amino acids. Each amino acid corresponds to 3 bases of DNA. The 4 DNA bases are guanine, adenine, thymine, and cytosine. And they're arranged into triplet codons on messenger RNA, which is the stuff that takes a copy of our DNA instructions over to our tiny cellular protein-making machines called ribosomes. So the messenger RNA contains 3,108 bases of RNA in the triplet codons, plus some extra bases at the beginning and end that are essential for making the protein. Finished messenger RNA contains exons, but in its early stages it also contains introns. The whole NLRP3 gene has 32,953 base pairs, so a lot can go wrong. 24 intron mutations are listed in the Infevers database, and so far they've all been classified as benign or likely benign. But that doesn't mean all intron mutations will be, because intron regions can affect how the messenger RNA turns out. For example, an intron mutation in a regulatory position could mean that your NLRP3 messenger RNA ends up missing a whole exon and your protein is cut short. And who knows what the functional impact would be. But it might also never happen because a mutation like that may be, as they say, incompatible with life. My point is there are still heaps that we don't know. So just because a CAPS-causing mutation hasn't been found, it doesn't mean that the possibility of an autoinflammatory disease, CAPS or otherwise, should be clinically dismissed. It could also be that you don't have a mutation in NLRP3 at all, but in one of the other parts of the NLRP3 inflammasome. Caspase-1 is a protease, the enzyme that activates interleukin-1 beta. If you had a mutation in caspase-1, maybe you don't even need the NLRP3 inflammasome to end up with too much active interleukin-1 beta. Maybe you have an as-yet unidentified mutation in one of the other proteins that keeps caspase-1 inactive under normal conditions. You can see where I'm going here. There are lots of players and many moving parts in the system. So I haven't even scraped the surface. While it's nice to get clear answers and understand what's actually going on in your body, it's more important that your symptoms are treated. Kineret or Anakinra is a fast-acting small molecule that blocks the interleukin-1 receptor so that neither interleukin-1 beta nor interleukin-1 alpha can bind. Using Kineret as a diagnostic tool is a valid clinical strategy for patients with autoinflammatory symptoms, even if no known mutation is found. For doctors who might still be reluctant to try this, there is literature available to support giving it a try.